Hi, my name is Katie, and today we are covering chapter 12, which I'll go over the chapter summary in a bit. So let us begin. So the overall chapter is basically about lambdas and streams in Java. The chapter introduces Java Streams API as a modern declarative way to process collections like lists without messy loops. It emphasizes what you want to do, like filter, map, or sort, over how reducing errors and improving readability. Lambdas are the glue of short anonymous functions passed to stream to hands-on, creating streams intermediate versus terminal ops. Lambda syntax and use in supporting functional interfaces is practical with examples like processing number lists or filtering songs. Um, yeah, that's about it. So now here we have page 369, so I'll just cover it over here. So basically, this is the introduction to streams and lambdas. So what's happening here? The kickoff. With the big picture streams process data sequentially, like like a conveyor belt for list items. And lambdas are mini functions you plug in to say do this to each item. No loops needed, focus on internet. So basically, imagine sifting through a playlist, streams into the flow, lambdas decide to keep it if it's rock. So this dual makes it go clean and fun. Next, we have page 273. So here we have page 373. Just highlight for you. So what's happening here? Sorry, before I go there. Basically, it's about why strings fix loop headaches. So what's happening here? It highlights how tiny loop bugs, off by one error, hide in similar looking code. Compilers catch syntax error but wrong output, which is sneaky. So streams plus the for each cut repetition, letting you chain ops like a data recipe. So ever debug a for loop that skips an item? If yes, streams say nah, like no, describe the recipe, filter, then map. So it reduces copy paste errors by 80% in the experience. Next we have page 374. Okay. So here we have page 374. What is happening? A common collection tells filter even nums, double values. Basically these are universal across data types. So name for clarity, filter, name clarity is filter map and distinct sorted. So no matter if it's numbers or songs, you always filter chunk, transform goodies, save duplicates, sort chaos. So here's a num list. Basically, we filter and then we sort it and then boom, it's readable. So like, oh, where does it begin? So here we have 52281. So here we're using the filter. So now it's just giving us 5 and 8. And then map plus 1 on the original, this will give us this output. Next, we're using the distinct. 5281. Remember that distinct gets rid of any duplicates. And then we have the sorted. So now it's going to sort the number sequence in order. And then boom, it's readable. Now we're moving on to page 375. So here on page 375, we are introducing stream APIs. So what's happening? Streams turn collections into pipelines, key methods, which is distinct for unique, and then we have filter. This is a predicate. So for conditions, and then we have limit for top end. Okay, so here we have the map function for transform, skip for ignoring, starter, sorted for order. So the chain dot filter rock tune. Let me just see something. Okay. So the string, where was I? String. Oh, sorry. Stream string from a list, chain not filter, limit. So basically, this is a declarative like organizing a pizza, stoppings, and not kneading the dough. Next, we have page 376. So, getting started with streams. So, what's happening? So, create fire.stream on collections, intermediate ops, limit filter. Build the pipeline, but don't execute. Return a new stream object. For example, printing shows slice ops, not data. You need a terminal op collect for each to trigger. So so here we have our example. I'll just highlight it. Okay. So here we have listed stream limit, which is 4. So this is just a blueprint. Now we have the add collectors to list. This is to bake it. So lazy eval means efficient, no extra process. Next we have page 377. Um 377. So yeah, on page 377 streams is recipes, terminal ops. Okay. So what's happening here? Terminal ops finishing the job. So any match, which is a predicate for exists. So the count for size collect, which is the collector for aggregating to list set and sum. So here we have any match, any rock zones, which is true or false. Count. Number 2, count how many are left. Which is long, and then number 3 is collect, bundle into list or sum, and then it reduces the data, and then number 4 is the first hand grab on the top, which will be optional. And yeah, next we have page 382. So yeah, this is where streams are lazy. So intermediates like fault and map default work. Tell terminal single, pass no multiples efficient for big data. So lazy equal to smart slow defines ops wait for go, basically the terminal. And then one sweep filter while mapping no backtracking, say a CPU like batching groceries. Next we have page 389. Okay. So lambdas as objects. So what's happening? Lambdas are synthetic sugar for functional interface objects. One abstracted method passed methods expecting that interface. Java invokes the method. So lambda equal mini object with one job. The method wants predicate. Lambda supplies this. It's like handing a vending machine a dispense candy button. Next we have page 393. Um, okay. So page 393. Lambda flexibility, no return frames. So what's happening? Void lambdas for action. So for example, for each print no returns params, for 0, for 1 no parents, x and y for multiple, which types optional. So the print only void lambdas is system printout, and then the 0, right? The 0 params is the method random, and then the 1 is the to upper, and then the multi is the compiler cases. Next we have page 394. So over here, spotting lambda methods. So what's happening? So you look for a function interface params, so which is predicate, consumer, function. So that's the lambda hook. So the method seek void to stuff, predicate, string, and then lambda alert. So the column predict for the text consumers for sides, functions, and transforms. Next we have page 397. So page 397 basically covers functional interfaces in the web. So what's happening? The functional let me just zoom in so you can see as well. Okay, so the functional equals exactly one abstract method. And then it defaults to static object methods that don't count, which is, for example, the comparator. Only compare is abstract. So it looks crowded, ignore the none of abstracts. The comparator has extras, but not compare. Solo, lambda, ready. So now we have page 402. Page 4, right, page 402. So this predicts in action. So what's happening? So here we have the predict. We just see something. Yeah. So the here we have the predict. So it takes an input, returns a boolean for testing. So it's the predicate. It's predicate. Sorry. And now the predicate is a yes or no gatekeeper for the drop filters, which is S. So yeah, that is it for chapter 12. Thank you for watching.